0.065% to 0.085% niobium. However, in recent years, weld failure accidents have occurred in the high-grade pipeline projects, especially in the girth weld. In the girth weld, the niobium in the base metal will be diluted into the weld, which promotes the formation of granular bayonet and a large number of coarse martensite and austenite components appear in the structure, which deteriorate the toughness of the weld. As it can be seen in the middle figure, with the increase of niobium content in the base metal, the low temperature toughness of the weld decreases. This phenomenon leads researchers to reevaluate the application of niobium in pipeline steel. Recent research results of our teamwork show that appropriately reducing niobium content and increasing vanadium content is conducive to improve the toughness of the hard-affected zone of the girth weld, as shown in the figure left. As seen in the figure, along with the decrease of niobium and increase of vanadium, temperature interval of low toughness is narrow, and when it comes to the temperature below 700 centigrade and above 850 centigrade, impact energy of number 3 of the steel with 0.03% niobium and plus 0.05% vanadium steel is higher. So we can make an assumption that niobium content in the pipe would be reduced, and niobium plus vanadium composite microalloying would be used to guarantee the high strength, meanwhile increase the toughness of that. As demand for X80 pipeline steel will be no less than 1.5 million tons per year in recent years, if 0.02% to 0.04% vanadium was added in X80 pipeline steel, demand for vanadium would be a huge number. And this is the research objectives of this project. The second part, research progress. First of all, 3 kinds of steels with different niobium and vanadium content are obtained in chemical content of number 1 steel is the same as X80 pipeline steels manufactured in steel mill in China, with the conventional idea of low carbon and high niobium. But when it refers to number 2 and number 3 steel, based on the metallurgical composition of number 1 steel, content of niobium is decreased and vanadium is increased. Three steels are obtained for rolling and pulling, just like an industrial production process, MCP. As the mechanical properties shown in the table, strength and toughness of 3 steels fulfill the technical requirement of X80 pipeline steel. Microstructure of base metal are similar, which is acicular ferrite. Phase transition points of the 3 experimental steels were calculated by thermocouple, and it was found that the temperature of AE1 and AE3 remained basically unchanged. When the relative of niobium and vanadium was changed, we also calculate the effect of temperature on the solid solution law of niobium and vanadium in austenite of the 3 experimental steels. in the stage of slab reheating. As can be seen in the figure, at the slab reheating temperature, which is 1180 centigrade, vanadium is completely dissolved in all experimental steels, but niobium is only partially dissolved in number 1 steel with a content of 0.068%. Niobium in number 2 and number 3 steel is completely dissolved. Figure in this page shows the precipitation morphology of number 1 and number 2 steel with reheating temperature 1180 centigrade and reheating time 19 minutes. Only a small number of large size titanium rich precipitated phases are observed. The size is about 100 nanometer. The results indicate that in the reheating stage, the key role in controlling grain growth is the dragging effect of dissolved niobium, rather than the panning effect of the precipitate particles on the austenite grain boundaries, such as niobium carbide or titanium carbonitrate. The purpose of reheating stage is mainly to eliminate the effects found in the casting stage and to redissolve the microalloying elements segregated on the grain boundary back into austenite. But with the increase of reheating temperature and the extension of holding time, the austenite grain size inevitably grow up. At this time, the reheating process is very important for the performance of pipeline steel. Figures in this page shows changes of austenite size along with the change of reheating temperature on time. The austenite grain size of the experimental steels are increasing with the increase of reheating temperature and the extension of reheating time. And we can see that the difference in austenite size of number 1 and number 2 steel before 1,150 centigrade is not visible, but it is obviously finer than that of number 3 steel. So it can be inferred that ability of the dragging effect of dissolved niobium is higher than that of vanadium, but difference of the 3 steels austenite size is not big, which is no more than 10 microns. This is the summary of research work. Mechanical properties of 3 steels are similar, which fulfill the technical requirements for X80 pipeline steel. In the reheating stage, with the extension of holding time and the increase of temperature, the grain size of austenite is coarsening, and the austenite of number 1 and number 2 steel is kept in a relatively fine state. After the reheating process, the precipitate phase is many large-sized particles, and the dragging effect of solid solution atoms plays a major role in hindering the growth of austenite. For the reheating stage, 1,180 centigrade and 19 minutes is the target process parameter, in which condition the niobium and vanadium elements are basically solid solution, and the austenite grains are finer. And the third part, next work plan. Next step and the precipitation law of metabolization and on the micro substructure characteristics during cooling. Okay, ladies and gentlemen, that's all for the report. Thank you for your attention.
Okay, thank you very much for that. That's a very, very clear presentation, and it looks as if you've made some good progress in a short time. If you want to stop sharing your screen now, thank you. Right, are there any questions or comments on this presentation? Okay, just a couple of questions from me then, if I may. You've rolled 3 steels, I think, so far. What plate thickness did you roll them to?
Sorry?
You've made 3 steels so far. What thickness did you roll them to? What plate thickness did you roll?
15 minimum. 15.
15, okay. My other question was, when you start off with a plate and then you produce a pipe from that plate, the properties change from the plate to the pipe, and it's really the pipe properties we're interested, and you can get changes in strength, but you also get a reduction in toughness during the pipe forming process. Do you think that your plates will still have the necessary toughness when they've been formed into pipes?
要问一下，就是说你
都是没事，李姐你给他翻译一下吧。
就是说你的钢板要形成钢管的时候，你的形成过程的你这个就是硬性就会下降。他就说你这个钢板的硬性能够确保你这个形成管以后这个硬性还可以达到要求吗？
对。
您的意思是，就是说钢板的性能能不能达到钢管的性能要求？
对，他说你杂质是板材嘛，但是你最后形成的是管线钢，就是你从板到管，它的性能是要发生变化的。他意思是说，就是在板形成管的过程中，韧性会下降的。以你现在的这个板的性能，能不能达到你到时候管的性能要求？
我展示的那个性能要求，就是对于板的性能要求，而不是对于管的。
但是就是说，最终你这个要求的性能，并不是要求你这个板的性能，最终要求就是你形成管以后的这个性能。那就是说，你现在在这个生产这个板的时候，你这些性能最后能不能确保你这管子性能达到要求？
可以确保那个管子的性能，因为能看到我现在共享的这个屏幕吧？这个最下边这一行要求的这个标准要求的这个性能要求呢，就是对于板子的性能要求，它已经考虑到了在板制管之后的性能变化，所以说尤其是低温韧性这一块是留了很大的一个富余量。
Okay, the size fine because this plate is the requirement is for the pipe. So if they achieve this requirement, they'd be okay.
Right. But my question was, in the plate it's okay, but when they form the pipe, the properties will deteriorate. But
yeah, because this plate is aimed to use for the pipe. So if they achieve this standard, will be okay.
Okay.
Yeah.
Okay. Okay, thank you. Are there any more questions or comments on this presentation?
Dave, I just have one small question. This is Vishwanathan from JSPL.
Fine,
right?
Go ahead.
Yeah, so very quick one. Was there any change in the rolling process parameters? Because now we are changing from one alloying strategy to the other one. So was there any change in the way plate was as in the resin start or the finished rolling temperatures and the CT?
What he said is about the rolling temperature.
I think the question was whether the rolling changes for the different
Was there any change in the rolling process parameters that was adopted?
Yeah. So the question is the rolling and the cooling parameters the same for all three steels?
就是说你在杂志这个就3个板带的时候，你这个杂质工艺都一样吗？
是采用了一致的杂质工艺，就是常规的 X80的工业生产的杂质工艺参数，我们就是采用了那个工艺参数来进行的中式生产，实验室的杂质是一致的。
Yeah, the same for the 3 plate.
Yeah,
they use industrial, rolling schedule.
Okay, so yes, the answer is the schedules were the same for all three different compositions, and there were standard industrial processing conditions.
Yeah, for
yeah, thank you.
X80 type. Yeah.
Okay. Okay, thank you very much. Well, I think we better move on to the next presentation.